So AI has been playing a big role in education. And I start with something small. I build math teachers. Let me show you an example of how this agent works. Let me shoot this example prompt. Say I want to learn about something like system of linear equation. And it's going to take my request and giving me a lesson plan. As you can see in the left side, it's going to create its presentation for its lecture in the middle. Now it's using the voice tools that I give him to speak. The TTS, which stands for text-to-speech. Now it's starting lecturing.
A system of linear equations is just two or more equations that we solve together. The goal is to find the one point.
And the right side is the agent panel.
Both equations true
it's for me to monitor the agent's working status and the two callings, and some original outputs of the large language model.
There are two ways to see this. Graphically, each equation is a straight line, and the solution is where the lines cross. Algebraically, the solution is an ordered pair that satisfies both equations. Here is an example system. Equation 1, y equals 2x plus 1. Equation 2, y equals negative x plus 4. Let's check if the point 1, 3 is a solution. In equation 1,
let's continue this demo.
3 equals 2 times 1 plus 1. That's 3 equals 3, true. In equation 2, 3 equals negative 1 plus 4. That's also 3 equals 3, true. Since both equations hold, 1, 3 is the solution. So the solution to this system is the point 1, 3. In the next step, we'll see how to find this point by graphing.
Yes, continue.
Now we move to the graphing method, the most visual way to solve a system. The idea is simple. Graph both equations as lines on the same coordinate plane. The point where they cross is the solution. Let's graph the first line, y equals 2x plus 1. The slope is 2 and the y-intercept is 1. Start at 0, 1, then go up 2 and write 1 to find more points. Draw the line through them. Now the second line, y equals x plus 4. The slope is minus 1 and the y-intercept is 4. Start at 0, 4, then go down 1 and write 1. Draw the line. Here is the graph with both lines. Notice they cross at exactly one point. Can you see where? The lines cross at 1, 3. That's the solution to the system, the same point we checked earlier. The graphing method lets us see the answer visually.
Yes, continue. So I'm going to stop here. If that's interesting, we'll continue to break this agent down. Okay, let's continue to look underneath this math teacher agent. We're using deep agents to create the math teachers. And here's the parameter that we're passing. Let's look at the tools here. Here's collections of tools for the math teachers to create the lessons and lecturing. First, we look at the lesson tools in here. It's a list of lecture control, lesson control. You have list lesson state, which is for him to understand the learner's level before creating the lesson plan. And you have other update, record, advance, and skip and save the lesson. There's all tools in here. It's all the functions. And you have lecture tools here. This tool is fun to build. It's just walk you through the slides here with the voice, and here's the subtitle of it. And you can here continue to play the lessons and stop pause the lessons. And you have the mermaid tools, plot tools, and material tools. This is for the card generations like materials and plot, two-dimensional graph here, and mermaid diagram tools, visuals. So these three tools are for the visual. The math tool is important. This is for verify the output of the equation. Make sure every equation is correct. And the search tool and fetch tool is for gathering online resource or database, whatever. And the memory tool is for saving some section memories or user profile memories. The user tool is for asking the user questions, whether it's advance the lesson, skip the lessons, or giving out random quiz. And the skill tools is for loading specific prompts in here, because different teacher have different subjects. So I'm thinking of loading some prompts, specific prompts, inject some prompts into the lessons. Okay, let's look at the system prompts here, where we guide the math teacher agent's behavior. So I'm not gonna read through everything here. I'm going to only talk 4 parts of this, which is roles and personas. We're gonna talk about teaching loops, and we're gonna talk about some rules that the math teacher must follow. We're gonna talk about some tool discipline. Make sure he calls the correct tools during the lecturing. So first, let's look at the roles here. So it's gonna teach mathematics only. It's not gonna give some medical, legal, finance advice here. It's gonna give a structured lesson with steps here, and recording checkpoint and progress. And it's gonna give a concise replies under 150 words. Let's look at the teaching loops here. There are 7 steps of his creating lessons. He's first gonna understanding the learner's level before planning and creating lessons for the students. And he's gonna teach one concept at a time. And it's gonna use visual if necessary. And it's gonna recording lessons. And it's gonna advance lessons. So there's lots of rules here, like cognitive law rules, Socratic rules, and math formatting rules, and visual rules, and memory rules here. So you can add as many as you want to make sure the agents behave well. And tool discipline is very important. So you make sure the agents call the correct tools. So introduce some tools for those tools are for the agents to reading, and those tools for the agents to write and compose lessons, and those for user gating. Just ask the user before doing some actions, and this is for internet search. And some rules contain some tool calling rules. This is just make sure every tool is calling is correct. Like verify math, like memories updating. So let's talk about there's 2 modes of my math teacher. One is for learning. It's just like basic Q&As here, and it's gonna give you short replies and with visuals. And lecture mode is different. It's gonna generate a list of cards with voice to walk you through the lessons. So it's overwriting lots of teaching loops here, and some rules for the sigmas, and some visual materials, 2D graph formatting rules, and tool calling rules. This is all kinds of data formatting rules and some examples here. So I walk you through the tools and system prompts. That's basically the math teachers, and backends for storing some section memories, and model is for reasonings, use large language model. And the middleware, there's tons of middlewares where we customize the agents like memories, injecting some section memories or user profile. Middlewares, there's one in human in the loop middleware that's worth mentions. It just inside the agent loop is gonna asking the user to continues. Now he's looping, asking me the questions, so it can continue to move on to the lessons. This miscall some tools here.
Now let's learn the first method for solving a system graphing. The idea is simple. Graph both equations as lines on the same coordinate plane, and find where they intersect. That intersection point is the solution. Go up 2 and write 1 to reach 1. 3. Draw your line through these points. Step 2. Graph the second line. Y equals x plus 4. The line is at 4, and this is 1. We go down and write 1. You're on the graph. You can see both lines. Notice they cross.
So I think that's it. I'm gonna end this video. So in the end of this video, I'm gonna just thanks for your times for watching this to the end, and I wish you good luck in your work and your study, and goodbye.